There are two forms of pyrolysis: fast pyrolysis and slow. Fast pyrolysis optimizes for renewable transportation fuels, and slow pyrolysis optimizes for biochar, particularly used on farms to condition and fertilize the soil. So let's walk through the process. And we see that we start with wet biomass in the fast pyrolysis at the top, which is then dried and fed into the pyrolysis process itself. Out of it come the pyrolysis vapors, and out of that step comes the pyrolysis gas, which goes on to oil recovery, and the char, which eventually goes to the soil. One of the nice things about these processes, both fast and slow, is that part of what is separated out during the process is used to further power and energize the process. So in this case, we have solids that are removed in the form of char. There is a heat generation station using that char, and out of it come fluidizing gases which feed back into the pyrolysis process itself. At the end, there is a pyrolysis product of char, but it's not clear that it's as good as the biochar coming out of the slow pyrolysis. But once we have gone through the solids removal and stored the biochar, we go into the oil recovery. And that oil recovery can also be used to help drive the heat generation process with the energy coming out of that in form of pyrolysis gas. And that also produces the stage where bio-oil is produced. Bio-oil is a thick, viscous fluid, and it is produced in a low or no oxygen environment. That's one of the primary. The fast pyrolysis, the temperature is around 500 degrees centigrade, and the heating rate, which is the rate at which thermal energy is transferred, is high as well, 1,000 degrees centigrade per second, which is more than 500 times faster transfer rate of the energy than is found in slow pyrolysis. And out of it comes the biochar, which is 15 to 25% weight, the syngases, which are 10 to 15% by weight, and the bio-oil itself, which is 60 to 70% by weight. The bio-oil is then put into a stage called hydroprocessing, hydrocracking, hydrotreatment, where hydrogen is used to separate the carbon bonds, and this allows transportation fuel to be created, and we'll talk more in detail about that in the next slide. For the bottom half of the screen, you'll see the slow pyrolysis, which primarily focuses on biochar and pyrolysis gas. Again, just like with fast pyrolysis, we dry the wet biomass. We're talking about the various wood and other straw, hay, any number of things that we've talked about before. It goes into the pyrolysis process. The pyrolysis vapors come out, the solids are removed, and clean gas is used to generate heat and drive the pyrolysis process itself. In both cases, the gases that come out of the heat generation step can be used also to help dry the biomass, but it may be more useful in the pyrolysis process itself. Out of the end of the slow pyrolysis process comes the biochar and the pyrogas. the pyrolysis gas. This is substantially a self-sustained operation, though there is other input of energy required. It is not entirely a self-sustaining process.